Hello everyone, I'm going to show you how we can set up Pfeifer in order to process experimental recordings. Right now we are looking at my MATLAB workspace, and you can see over here I have put a time signal into a folder called original. I have a folder called converted, processed, and split. We'll see later on in the video what these are going to be used for, but it's helpful to set these up before you actually initialize Pfeifer. So in order to actually run Pfeifer, simply type it here in the command window of MATLAB, and what you'll see is these two windows open up, which are more or less the two windows that we'll be using throughout the actual processing of this experiment. So Pfeifer stands for a preprocessing framework for electrograms intermittently fiducialized from experimental recordings. For this tutorial, we are going to process experimental recordings from the Auckland Research Group that are stored on the Edgar online repository. So that can be found at edgar.ski.utah.edu. So I am taking a 15-second recording of the potentials measured on a swine study, which it has potentials simultaneously measured on the epicardium and the torso surface. Because they were measured simultaneously, we can actually process them simultaneously in Pfeifer rather than doing them in two steps like we would normally do it. So in order to actually run Pfeifer, the first step we should do, I guess before going into that, I should show you that this window we call the data organization window, and this more or less sets up the data I/O for Pfeifer. And over here is our workbench, which sets up the tools and the files we plan on processing. So here in data organization, we actually have to set up the data I/O of the experiment. In order to do that, we have to initialize these two helper files, the script data file and the processing data file. To do this, we just click Save. We navigate to our directory, so we see these files that I set up originally. I'm just going to save that there. Do the same thing with the processing data file. And now we have both those files saved there. We want to actually make the files accessible to Pfeifer. In order to do that, we actually have to package the pot files into a TS structure. If you actually want to learn more about this TS structure, I suggest you read the manual we have on Pfeifer's website. But using this TS structure, you can include metadata that will be inherited by all the processed files. So you can more or less put in as much information you want up front into the raw files, and it'll be subsequently passed down to the processed files. So in order to do that, the first step we have to do is actually do this file converter step. So for the input directory, we will be navigating to the original data. The output directory we'll put to the converted data. We have to point the Pfeifer program towards the actual pot valve structure. Because the structure is non-existent for this data run, there's literally just a structure with only a potential value matrix in there. Pfeifer tells us that there's only one variable we can choose from as being the potential value matrix, and it is, of course, the potential value matrix. So we then select our runs. Because there's only one, I just have to select here. And then if we convert selected runs, it does it pretty quickly. So now we're done with that. Now the next thing we would do, if we had a very long run, what we would do is we would go to file splitting, set the output directory as split, and then set the length of the file to be about 15 seconds. At least for ischemia, that's what we found to be right. For faster changing events, you might want to shorten that. And then you split the files after selecting the files you want to split. However, I know this Auckland data is only about 13 seconds long, so we shouldn't have to actually split it. Okay, so let's set up the rest of our data I/O for the actual processing step, not just the converting. So the input directory, we're now going to use the converted data as the input. We want to use the processed folder as the output. The sampling frequency was 1,000 hertz, and the baseline width we want to keep about 5. Data that wasn't acquired by Utah can't actually be calibrated here. So it has to be calibrated before it actually comes in. Pfeifer necessitates the raw recordings be time-aligned, calibrated, and mapped prior to being loaded into Pfeifer. The final data I/O steps is to allocate these run files, or these continuous recordings, into groups and run groups. Groups separate the electrodes stored in a single pot valve structure, so the pot valves associated on a run-by-run basis, and allocates those electrodes into various groups. So for example, for the one file we will be processing in this tutorial, the pot valve structure contains electrodes from the epicardial surface and the torso surface. And we want to tell Pfeifer which electrodes belong to which one of those surfaces, so they are saved in separate files, but are processed at the same time. The second type of grouping we have is what we call a run group. And these are all runs, a run group are all runs that were recorded under similar group settings. By this, I mean, if you have more than one run, unlike what we have here in this tutorial, you may have some of the runs were recording only torso potentials, whereas the other runs recorded torso and epicardial potentials. These two groups would belong to two separate run groups. For this tutorial, let's set up the one run group and the two electrode groupings that correspond with this run. So to set up a new run group, which we will call Auckland, corresponding to just the first file, but if it corresponded to the first 5, we would do 1 through 5, or the last 5, 5 through 10, so on and so forth. But again, we're just looking at one file, and we can look over here on our workbench to actually see that, and then it allocates that Auckland run group to it. Now, we want to actually allocate the electrode grouping, so we go to New Group. We name the first one Epicardium, and we allocate the first 239 electrodes to the epicardial recordings, and we're going to give that an extension of -EP. If I knew electrodes that were bad here, then I could list them and they would be removed from further processing. So we would list this as just 1, 2, 3, 1 through 5, so on and so forth. And you'll see later on in the processing where this will become useful. So we have to now actually create a second run group to take care of the torso recordings. So torso with lead numbers going from 240 to 171 values above that. So 410, if my math is serving me correctly, or 411 perhaps. Yeah, 410. Okay, and we'll give that the extension of -TS. And again, because this is not Utah data, we will not be using a mapping file. So again, just to go over what we just did, we created a run group, and since we only have one run, we only have one run group. But that one run has two electrode grouping, the epicardial electrodes and the torso electrodes. The torso electrodes are essentially in the pot valve matrix rows 240 through 410, which is why I had to check my workspace just to confirm. And the epicardial electrodes are rows 1 through 239, corresponding to electrodes 1 through 239. The output files that are saved will be appended with this tag, so choose a smart one. The group name and the run group name will be stored in the metadata for that run. All right, so now that we are done with our data I/O for this one run, we can now actually begin processing. However, before processing, we should take a look at this workbench to get ourselves familiarized. So again, because we are not using Utah data, we will not be able to calibrate signals. We do not have bad leads yet, but even if we did, selecting blank bad leads would essentially make them 0 in the output files, and since we don't want to actually change the output files, we're going to unselect that. We'll see how bad leads can be used and still not be blanked at a later time period. We want to apply a temporal filter. We want to do baseline correction. We want to detect fiducials. And we want to do auto fiducialization. All right. So now that we've got these the settings that we want selected, we can select our run, select run script, and what we see is the continuous recording. So this is the RMS of the signal measured across the epicardium and torso. So the goal of this window is to actually isolate a beat which can then be fiducialized, and then those fiducials will be auto-fiducialized, will then be propagated to the subsequent beats. As we have several beats in this recording. The purpose of Pfeifer is to only fiducialize a single beat and then have those fiducials propagate to the next beat, saving the user quite a bit of time while still setting very accurate fiducials. In this window, we can actually switch to only look at groups. So we see the RMS of the epicardial signals and the RMS from the torso signals. We can also look at individual leads, whereas we see epicardial electrodes, and we see that the raw data already had the bad leads negated, so that's nice. If it wasn't, you could then enter in these numbers into the bad lead field, so you could literally enter in 1, and it would be represented here as a bad lead. So we see here all the individual epicardial recordings and all the torso recordings. So let's isolate our beat. Let's go back to the global RMS. We want to choose 2 isoelectric points. So holding a left click, click on one isoelectric point preceding the P wave and one isoelectric point after the T wave. After we've done this, we can then apply, bringing us to the next window, which is just asking us to confirm that we've chosen 2 isoelectric points, which we have. So I will apply this. Now we are in the third window, the fiducializing window, and we have a list of fiducials here on the right that we can choose to actually fiducialize this. So P wave is already chosen. I will place a new T wave with a right click and drag without letting go of the right click, and then letting go on the outer bound of that P wave. I then can switch to QRS complex and do the same thing. I can do the T wave. Remember, right click to place a right click. Should really use a mouse, not a trackpad. And then finally place the T peak. And now that we have those fiducials placed, we can then apply and then propagate them to the subsequent beats. And we can see that this happens quite quickly. Now we can see the original beat we fiducialized along with each subsequent beat that was fiducialized by our program. Now Pfeifer is telling us that there are quite a number of faulty beats. This could be because of the bad leads already taken out, and then but the algorithm is trying to find QRSs in these bad beats, leading to quite a large variance in where it is thinking that the T wave is. But it does a very good job actually finding those in subsequent beats. We can review the beats and actually edit the fiducials on subsequent beats by going to this review panel. Once we are content with these results, we can hit apply, and the files will be saved.